Today we are going to present a design for a miniaturized, affordable, and quantifiable vascular Doppler. The vascular Doppler is a diagnostic device that sends either pulse wave or continuous wave ultrasound signals to a blood vessel and converts the Doppler-shifted reflected waves into an audio signal. It enables clinicians to assess a patient's blood flow and diagnose multiple disease states. Peripheral artery disease is commonly diagnosed with the vascular Doppler, and it is the narrowing of blood vessels supplying the limbs due to a buildup of atherosclerotic plaque. It reduces the rate of blood flow and can lead to the development of symptoms such as ulcers, pain while walking, and poor wound healing, and even the loss of limbs. It is estimated that peripheral artery disease affects 200 million people worldwide and 8.5 million people in the US. An increasing incidence of peripheral arterial disease in the US warrants a need for a portable, affordable, and more effective vascular Doppler.
Voice of customer surveys and interviews with clinicians ranging in training level from medical students to specialists such as vascular surgeons and interventional cardiologists resulted in initial design inputs and criteria. Using a weighting system based on feasibility, ease of use, and cost among other categories, the features deemed necessary to improve vascular Dopplers were found to be a sufficient speaker, a rechargeable battery, and the device itself should be reasonably small enough to fit in the pocket of the user. One feature of the improved device also included analysis of the waveform. However, the solution to this issue varied in the responses from our voice of customer based on the level of training of the person being interviewed. Once it was determined that the device would be pocket-sized, the electronic components of the device were selected with the size in mind and soldered onto PCB for fitting into the 3D printed housing of the first prototype.
So that then resulted in our current prototype. You can see here on the left is a picture of our final prototype, which contains all the design outputs other than the hydrogel tip. It should also be noted that the transducer here in our current prototype is actually from the on-the-market fetal Doppler. However, we have designs and plans for our next prototype to create our own transducer. On the right, you can see the app that works in conjunction with the Doppler, and it has a number of customizable features, including patient data, waveform analysis, waveform display, and the ability to save patient data to an electronic record. So we have the device, but how good actually is it? How does it fulfill our need? That's what we looked at. We compared our current device to a currently used vascular Doppler at the University of Minnesota, a Parks Model 811B. Here we can see that there's a volume decrease of about 48.6%, a weight decrease of about 69.4%, and a cost decrease about 78%. And then how well does it work? How do we test our efficacy? So what we did is we took that Park 811B and we took our current prototype and we measured the carotid artery of a volunteer. Then we analyzed the audio output with a spectrograph, which you can see here. On the left is the currently used Doppler, the Parks 811B. On the right is our current prototype. You can see that there's some similarities and some differences. Of course, one of the main ones being the difference between the high peaks, which correlate to the blood flowing forward, and sort of the low frequency troughs, which correlate to the blood flowing backwards. You can see that in the currently used Doppler, the 811B, it is much more distinct than the prototype, and that can also be heard in the audio. However, it's still distinct enough to make out, and with additional filtering and waveform analysis, it can be likely just as good.
So, in summary, the need for an improved vascular Doppler is clear with an increasingly obese and aging population. The lack of accessibility clinicians have with vascular Dopplers while working, paired with hospitals being reluctant to purchase more expensive options and opting to rely on older models, justifies the creation of an improved vascular Doppler. The device our team has designed makes improvements in portability, user interface, and cost while keeping all components in a singular housing for ease of use. The addition of a phone app also gives the clinician a much wider range of features and customization to make their job as easy as possible. Thank you.